Good afternoon, everyone. It is David Schlotthauer here, and I am so excited to present you all my 8th El Nino update, May the 8th, 2023. And of course, in this video, we are going to get into as much detail as we can with how strong El Nino is going to get this year and how that's going to influence the Atlantic hurricane season and the upcoming fall and winter pattern. So as always, what I like to do is look at the latest ENSO recent evaluation, current status, and predictions from the National Oceanic Atmospheric Administration. This is a PowerPoint, so we're going to kind of go through a little bit of detail, and then we're going to be looking at sea surface temperature in more detail and other cool things in the video. So let's get started here. So this is as of May the 8th, so this was just updated today. That's why I make these videos on Mondays on the latest ENSO. And so, of course, we do have an El Nino watch that is currently issued by NOAA at this time. We're looking at near normal to above average sea surface temperatures, and there is a greater than 62% chance that El Nino will develop by summertime, and then possibly as high as 90% by wintertime. So we could see how the sea surface temperatures have changed over the last 3 to 6 months, and we can see a lot of these orange and yellow colors here recently. Literally since February, we have seen a huge increase in warmth in the equatorial Eastern Pacific, and this is usually an indicator that we are starting to see a potential El Nino that is brewing, and El Nino stands for the little boy in Spanish, okay, because it happens right around Christmas time when it's at its strongest. And so when we look at our Nino region sea surface temperature departures recent evaluation, we can see different regions here mean different things. So the El Nino 4 region is in yellow. It's this yellow box right here. The El Nino 3.4 region is this box outlined in black. See the black outline here? That is the El Nino 3.4 region. This is the El Nino 3 region in red, and this is the El Nino 1+2 region in white. It's boxed in white with that black box outline. Okay, so now you know a lot of your regions. We can see some significant warming has happened in the Nino 1+2 region. Even in the Nino 3 region, we've had a huge rise in temperatures recently, and the latest departure now is 0.8 Celsius. However, we're not looking at an El Nino just yet. We're right below that threshold in the Nino 3.4 and Nino 4 region. We need to see these two regions to get above 0.5 Celsius or warmer. That's how it works, okay, when it comes to monitoring ENSO or monitoring La Nina or El Nino. There's thresholds. Negative 0.5 or lower is La Nina, plus 0.5 or higher is El Nino. So in the two regions here, we're still at neutral, even so Nino 3 and Nino 1+2 are clearly in a weak to strong El Nino state at this time, but not really declared yet by NOAA because of the 3.4 region. So we're going to kind of skip ahead. We're looking at this. This is the Central and Eastern Pacific Upper Ocean 0 to 300 meter weekly average temperature anomalies, and there has been some pretty substantial warming. We were way in the negatives here in the subsurface, so this is upper ocean heat content, by the way. And recently, you know, it's kind of leveled off here in mid-February, right? That's when we were starting to see signs that an El Nino is looking possible. But recently, really look at the huge uptrend in heat anomalous below the surface of the ocean here as of May. Really significant, and that's why it is now looking very likely we're going to have a pretty strong El Nino, possibly a super El Nino perhaps, and we'll be looking at why that is in just a little bit. But right now, very warm in the subsurface waters. We're going to get into more detail here on this. We're not going to cover much in the PowerPoint here because we have it actually in this tab up here we'll look at, and it has a movie on the progression. But long story short, these water temperatures here are definitely have warm. Look at this, just substantial amounts of upper ocean heat content and subsurface temperature anomalies that are well above average. I mean, in the 2 to 4 degree range in the below the surface of the ocean. All right, so that's what that is. Let's take a look now at our wind anomalies. Really nothing has changed here. Still near average trade winds in the last 30 days, and the 200 millibar winds, that's about 39,000 feet. Those winds have been a little bit above average, so still seeing that Walker circulation work its magic, keeping the west wind bursts from really propagating eastward. We're going to start seeing changes here probably within the next month or so, where we're going to slacken the trade winds more over the central and eastern Pacific, where the upper level wind pattern also changes. So when we look at the MJO here, our heat content evolution, definitely a lot of Kelvin waves moving eastward with time because of the slackening of the trade winds. We can see how this has evolved in the low levels over the last year or so. The blue colors indicate stronger than normal trade winds. Orange colors indicate weaker than normal trade winds. And at times, winds do reverse. They come out of the west at times, what we call west wind bursts. So we can see here how this has kind of back and forth. Stronger or weaker than normal trade winds here. Stronger than normal here. Weaker than normal here. And stronger than normal here as of early May, late April timeframe. But we're starting to see indications now. We're going to start to get another weakening of the trade winds, and possibly at times we might see reversals of the trade winds too. All right, so that's that. The MJO is very active MJO in response to that El Nino that is developing. So as of right now, they filled in our box here, negative 0.2 Celsius as of the February, March, April 3-month mean average. So it has come up a little bit, but still relatively in a ENSO state as of this video. So that's the last box that has been filled in, just for your guys' information. So now looking at the CPC probabilistic ENSO outlook, definitely an 80 to almost 90% chance that El Nino conditions will develop or will persist through late summer, early fall, and perhaps early winter, with neutral conditions very low, as well as La Nina. I would not be surprised in the next update, when this graph updates, that there is no chances of La Nina at all. It's 0% chance. All right, so just letting you all know about that. We're going to skip that because that doesn't mean very much, because this means a little bit more, and it's more relevant to with what we'll be looking at. As of the 3.4 region here, this was recently updated. They are now calling for a 3-month mean sea surface temperature average of about 2 degrees Celsius. That is very significant. All right, think about, let's go back one frame. Think about this right here. All right, remember how we reached 2.6 here? Well, imagining that over here possibly. So we could be looking at sea surface temperatures anywhere between 2 degrees Celsius, perhaps even 2.5 Celsius by this winter time. It's a very strong El Nino, definitely very strong in its category. Either way you put it, it's going to be a strong El Nino. There is nearly 100% chance that's going to happen. It's still to be certain on how strong will it get, though. Will it be very strong, which is 2 Celsius, or will it be very strong or super El Nino if it's 2.5 Celsius, right? So what we're looking at here is clearly a big signal that we're going to have a big El Nino, and it's going to mess with our hurricane season, and it's going to be very impactful for this upcoming winter season, which you all need to definitely be aware of. I know we're just getting done with winter, but it's a good idea that we focus on that. All right, so here's a look at the last 90 days of sea surface temperatures. Okay, and we're looking in this box right here. So I've boxed this in black. And you can see how this has all evolved. And recently, El Nino is really starting to show itself. You can see it right there, really getting that warm tongue going. It is to be expected if we're going to see this warm water expand westward. I think we're going to see that happen here because relaxing in the trade winds will allow more upwelling of water and will make things even warmer. By the way, sea surface temperatures here off the coast of Central America, that includes for southern Mexico, right over here near, like, you know, just west of Venezuela, sea surface temperatures are extremely warm, 31, 32 Celsius. So this Pacific hurricane season is going to be a very active one because of the El Nino that is in place. Now, another tool that I like to look at here is the subsurface. Now, remember that graphic that I showed you in the PowerPoint and we didn't really get into much detail? I wanted to save that for this. You can see ever since early March of how our subsurface equatorial Pacific temperature anomalies have evolved. All right, so this goes from 120 degrees east in longitude all the way over to 80 degrees west longitude. So literally across much of the Pacific here. And look at just how warm these subsurface temperature anomalies are. They're up in here, 2, 3, 4, even 5 Celsius above normal waters below the surface of the ocean. So there's a lot of warm water packed down there below the surface, and when it surfaces, we're going to have a big El Nino, I think, on our hands to deal with for the fall and winter time. Even summertime it's developing right now, and all this warm water that you see here is really upwelling. Also, equatorial temperature, actual sea surface temperatures here. This is not anomaly. This is basically the thermocline index. And what we're looking for is all this warm water. See how this is sloshing eastward here? It's kind of like warm water in your fish tank, just kind of sloshing. It's just moving. It's just moving towards the east. And that's a signature of a developing El Nino that is on our hands. All right, and that just stopped working. So let's go back and you can see here how that has all evolved. Even 28 Celsius, not far below the surface. So that is quite warm, and that's surfacing right now, and that's going to lead to a pretty healthy looking signal. So now, this is now the actual CFS V2 forecast Nino 3.4 sea surface temperature anomalies. This is raw data, so we can't rely on this entirely. But there's a ceiling on this, and the ceiling is 2.5 Celsius. That is right here. So to make this easier, let me use my black line here so you all can actually see where that actually is located here on this picture. So look at the black dotted line here. That is actually touching this black line, which is 2.5 Celsius. Now, while that does not seem like a lot above normal, it really will change our global weather pattern. I promise you, it's going to disrupt things, droughts where you don't expect them, heavy rain, flooding, mudslides, debris flows where you don't want to have them, like in Peru, in California, in the deep south of the U.S. This really is going to mess our weather pattern up. If models continue to indicate a very strong super El Nino, it's going to be a big deal. Look at some of the ensembles up here. Anywhere between 2.5 and 3 Celsius. Some of them are off the charts. I don't know how far off the charts they are, but I'm sure some of those members are going all the way up to 4 Celsius above normal. Which would be a disaster. It would be a very, very strong El Nino, something that we have not ever experienced yet. All right, so now another tool that I like to use is our Southern Oscillation Index. This is basically a measure of pressure patterns across the equatorial Pacific. 2 locations are measured with pressure. Tahiti in the central and eastern Pacific, Darwin in Australia. So over the Indonesia, Indian Ocean, that's where another pressure measurement is taken. So we can see when the Southern Oscillation Index is in the negative state, all right? So when you see negative numbers here, This is your neutral, 0, right, on the line. Okay, the black line, and our red lines here are negative. So when this is in a negative state, the pressure pattern is reversed. Darwin has higher than normal sea level pressure, which is in Indonesia, Australia, and India. Then the pressure is below average in Tahiti, which is in the central and eastern Pacific. Why is that important? Well, when you get lower than normal pressure, so let me kind of use my map here for reference. So here's Central America, here Peru, here's Australia, here is Papua New Guinea, here's Indonesia, Philippines, Malaysia, Singapore, those areas. So when we look at the pressure pattern, Darwin is right here to be exact, and the other pressure measurement is over here in Tahiti. I know it doesn't say Tahiti, but it is, I promise, it is Tahiti. So when you get lower than normal pressure here, so let me kind of draw this up. So when you get lower here and then kind of higher than normal pressure here, basically your trade winds are weaker. They're blowing, but they're much weaker than average. Okay, when you get a stronger pressure response, so lower than normal pressure over Australia, higher than normal pressure over the central and eastern Pacific, then you typically get stronger than normal trade winds. That induces upwelling of cool nutrient water over here in the eastern Pacific and blows it all across the central and eastern Pacific, right? That's a La Nina. But when our pressure patterns relax and the trade winds relax, this warm water over here in Papua New Guinea, Indonesia, and India is allowed to slosh eastward. Over months, it can take up to several months to happen, right? But when it occurs, we get an El Nino. So hopefully I made sense there. Okay, I'm trying to do all I can here to being one of the better ones out there that explain these things. So now the GFS ensemble, what is it showing? Are we going to get any more reversals or slackening of the trade winds? Well, the GEFS, which is our ensemble forecast, says yes. We are going to get another slackening with the trade winds. We can see the red colors here indicating very weak trade winds. I think they'll be blowing, but very weak, lots weaker than normal. These blue colors indicate stronger than normal trade wind anomalies. So we can see here we're probably going to get another reamplification and another significant subsurface warming event, even at the surface of the ocean too, because of the slackening of the trade winds here beyond May the 10th and the 11th. I think the May 13th through the 23rd, we're going to have very weak trade winds that will last quite some time here, coupled with the Kelvin wave and an MJO phase that favors this area. So I think we're going to have a really impressive warming event again over the central and eastern Pacific. Along to go with that, this is a look at the latest European model ensemble forecast, also an indication that the trade winds will be weaker than average. Also in the Atlantic, which we will get here in just a second, how that will relate to the upcoming hurricane season, because some of you are probably wondering, David's just talking about El Nino, but is he going to talk about hurricane season? I'm going to briefly talk about it though, but on the 15th of May, we're going to focus a lot more on the hurricane season than we will on ENSO, since things haven't really changed much by that point. So this is the north something MME model. Okay, and this is, where's my epic pen? There we go. We can clearly see this is what it looked like on February the 7th. Okay, so we're going to compare models here and the trends, how it has led up to this point. So we can see the subsurface temperatures or sea surface only about a half degree, right, by August. We thought maybe it's not going to be a strong El Nino, but look what has recently happened. Look at this trend upward. Now, we're looking at more of a moderate to strong, maybe even a very strong ENSO by August. So a huge trend up here on the NMME model forecast for August 2023. Why is that important? Because that just tells us that conditions are really favoring El Nino now, and we're not seeing a turnover back over to La Nina. What might bolster this is a little bit of a negative phase of the IOD, or Indian Oscillation Dipole Index too. which could also entice higher than normal sea level pressure readings there, which could help bolster and intensify El Nino quite nicely. That's according to this forecast. What does the CFS model actually show? Let's take a look at that really quickly, and we can see very, very, very utterly strong signal. Absolutely sickening to see this signal show up on the climate forecasting system model. But what does that mean for the Atlantic hurricane season, you might ask? Well, let's take a look at it really quickly, because for June, we're looking at above average anomalous amounts of tropical wave activity coming off of Africa, and maybe a little bit more rainfall than average over the Western Atlantic basin, really close to the U.S. And this could continue all the way through August and even into September with near average anomalous, but below average over here. So it's still a little uncertain exactly how El Nino is going to influence the Atlantic hurricane season. We can see this on the NMME forecast, where it does indicate here that there's going to be a wetter than average pattern over the Atlantic, okay, which is quite interesting despite our strong El Nino that is developing. I wouldn't be surprised if this trends down or drier, but at the same time, with the very warm Atlantic and the very warm horseshoe along the Iberian Peninsula, it wouldn't surprise me at all if we get a very busy Atlantic hurricane season, which those will be finalized for next week's video on Monday. So as far as the winter forecast goes, we are going to use the CANSIPS model. We could use the CANSIPS, why not? This pattern is very impressive for El Nino. I mean, look at how strong this actually is. By January and February, very strong Aleutian low out here, strong zonal flow cutting across much of the United States. That's going to favor, again, above average rainfall for California, for the Four Corners, the Deep South, and the Southeast, with possibly below average precipitation and snowfall with warmer than average temperatures across North America, central and northern portion of the United States, including the Pacific Northwest. So it could be another strange winter for 2023 and 2024. Well, that's going to sum it up for today's El Nino update, May the 8th, 2023. I hope you all have a great rest of your day. Share this with your family and friends on social media, and don't ever forget to subscribe, share, and like. You got to get this out to a lot of people because, again, this is going to have a world climate impact when it gets into full swing here by late summer into early fall. My next El Nino and tropical update will be on May the 15th, 2023. That will be next Monday. See you then.